So looking at the free body diagram, just to make sure everyone's is correct. Like the last one, we're cutting through parallel to the XZ plane. Our internal normal force has to be orthogonal to that plane. In this case, that means that P points along the negative y direction, like we saw in the last one. Putting our thumb in that direction, that torsion, we're going to assume is positive around that axis. So it's going to be positive also around the negative y direction. And like in the previous one, that means that we can have one component of our shear force in the x, one in the z. I'm going to assume they're both positive. And I'm going to assume that the bending moment components, I'm also going to assume are positive around the z and positive around the x-axis. So VZ, MZ, VX, MX are all around the positive axes, which we chose. P and T are negative around, or are around the negative y-axis as a consequence of the surface of the cut that we took. Using that free body diagram, then, we can go and write our equilibrium equations. So continue there, if you haven't already, to find the sum of forces x, y, and z. Looking at the moment equation, again, I would suggest taking it around C to eliminate those three forces from appearing. We have the three internal loads, MX and MZ, or MX around the I, MZ around the K. Again, in this one, we have a negative TJ. What we have here that we didn't have in the last one is we are applying this twisting or this moment around the vertical aspect of the pipe with a value of negative 30 pound-feet. That did not appear in the force equations. It does, however, have to appear in the moment equation. That negative 30 we put right in here. Everything needs an ij or k with it. It appears out here as a couple, not in here as a force. So 4 couples in this case, 3 of them internal, 1 of them applied. We then have the cross products, r cross f2, r cross f1 with the appropriate distances and the appropriate values for f2 and f1 here. Again, we want to make sure that our units are consistent. This is going to be in pound-feet, and the 30 was given to us in pound-feet also. So all of our units that will come out will also be in pound-feet. Especially in the English unit problems, we could very well be given this in like inch pounds and given this in foot pounds. We want to make sure that they're compatible, either everything in inches or everything in. If we expand out the determinants and group our like terms, grouping the like coefficients in front of the ijk, we'll get mx as positive 20 foot-pounds. T will be negative 72 foot-pounds. And mz will get a negative 178 foot-pounds.